Geometry Unit 1, Lesson 9. I can classify polygons by angles and sides. So, a polygon. Well, a poly, if you look at the front here, if you look at the prefix, poly means many. And gon actually stands for side. So a polygon is many sides. And it's a closed figure. I want to emphasize closed. That lies in a plane, and it's formed by connecting the endpoints of at least 3 segments. So here's an example of 2 polygons. You can make yourself at least 3, so here's 3. Makes a triangle. You can't close it with 2. It would just be open like an angle, like this. If you have 2 segments, it's not enough. But I can use more. I can use maybe 5 segments. 1, 2, 3, 4. And notice that's still open. So what do I mean by closed? Close it up so nothing can get out. That's 5. And these are the endpoints. And what these here are called, a single one, like in an angle, is a vertex. Like this would be a vertex of an angle. But the plural, vertices. So there are many vertices around the polygon, and it's closed. A couple other non-examples. So here would be one leaving this open. That's not okay. Another good example is maybe this. And you can see this here. You're not allowed any curves. They have to be segments, okay? They have to be straight segments, no curves. And the last one that I like, I'm going over my 2, is I'll do this one. Look how this one like twists and folds in on itself, so you can't go through itself, okay? So this bit right here is not okay. Can't cross over yourself. So these are the non-examples, what's not okay. These are the examples that are. So if we turn the page, let's take a look. Our objective is to classify. Remember what that means, is to put things in groups according to their measure. And so we're going to classify this a bunch of different ways today, but here's one. We're going to classify it by the number of sides first. So up here you see by the number of sides. That's the classifying. And each of these has a different name. For example, I'm going to sketch a picture and write the name of the class for each one, and I'm going to do it quickly. 3 sides, I think you know, is a triangle. 4 sides, I could make a square, but that's not the class. It just has to have 4 sides. And anything with 4 sides is called a quad for 4. Quadrilateral. And it's all about the prefixes today, guys. All about them. So quad means 4. Oh, I can't see that very well. Go with this. Quad means 4. Tri means, that's right, 3. 3 angles, 4, and lateral, actually, this right here means side. So 4 sides. 5 sides is a pentagon. Prefix penta for 5. 6 sides hexagon. And these prefixes are very, very helpful. Hex for 6. 7. Now it starts to get hard to draw these. I'm going to sketch them. 1, 2, 3, 4, 5. Let me see here. 6, 7. Yikes. This is called a hep. Hepta is 7. Heptagon. 8. You've seen this a lot of places. 1, 2, 3, 4, 5, 6, 7, 8. Close them up. So octagon. Think of an octopus with that prefix. 8. 9. Gets really hard to sketch here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a nonagon. Look how non kind of looks like 9. And now 10, 11, 12, this gets pretty nuts, so let's just do the best we can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I did a terrible job there. You see it's actually starting to look like a circle, isn't it? And this here is a decagon. Keep thinking about these prefixes. Think of some other words that might start with that. Like a decagon, think of a decade is how many years? 10. Or decimal, right? It's in groups of 10. Okay. 11, I'm just going to go ahead and not embarrass myself sketching it, but instead I'm just going to say it's un decagon. Think of Spanish, let's say. Deca is like diez, and un is like uno. Uno diez, 1 in 10 is 11, but it's un deca, 1 in 10 is 11. This is 1, and that is 10. And I tell you that because now look at 12. Do deca gon. Like dos deca. So dos deca, 2 and 10. Do deca. And if we just have n number of sides, we can say n gon. So for example, for 20 sides, I would say a 20 gon. And so on. Really look at the prefixes. It's what's going to help you when you forget. Remember, for example, octagon, like an octopus, is 8. Nonagon looks like 9, and so on. I think the hardest one is heptagon here. Hard to remember that that's 7. In the Olympics that just happened, the heptathlon had 7 events out in the track and field. That is classifying with a number of sides. So if I say, please classify this polygon by its number of sides, you say 7 sides, heptagon. Now we're going to classify differently. Here's 2 new titles, convex and concave. So I'm going to sketch a stop sign really quick here. Stop sign is an octagon. All right, and then I'm going to do a block letter L. Look at the difference. See this big dent right here? This big dent right here is concave. There's no dents, it's just a little spiky. That's convex. Okay? But specifically, convex, if you extend any side, extend any side in both directions, do you see how it does not pass through the middle? Take any side you want. None of them pass through the inside of the polygon. Whereas over here, if I extend this side, it doesn't pass through the middle. But look what happens if I extend this side. Right here is the problem. Passes through the middle. So convex is a polygon where no extended side passes through the middle. Passes through the inside, let's say. And here, this is a polygon where at least one, but an extended side passes through the inside. Okay? So, the way I kind of remembered it, because I didn't always remember convex and concave, But I remembered concave. You can see the word cave in there. This is my silly way of remembering it, but I always thought of a cave like this big old dent, like someone took a hammer to this and went boom, and put this big dent in it. I always thought of this dent kind of like it was a cave. I know it seems a little silly, but that's how I remember concave. But the technical definition, extend the sides, it goes on the inside if it's concave. Last but not least, we have classifying polygons by congruency. So in this situation, we're talking about are sides congruent or are angles congruent? So if you look at all of these sides have tick marks, so they're all equal. Look at the prefix. Equi means equal in both of these cases. So this here means equal. But then what does lateral mean again? Well, if you remember from the very beginning of this, lateral means side. So equal sides. Here, angular, you can tell, means equal angles. So here, all the sides are equal or congruent, and here, all the inside, the interior angles are congruent. If you have both of these different situations happening at the same time, like this diagram, the angles and the sides, we call that regular, which sounds kind of weird because you wouldn't think, but regular means equilateral and equiangular. So if I ask you to classify it based on congruency, you'd say, oh, it's an equilateral octagon or an equiangular octagon or a regular octagon. Okay, remember to classify. Good luck.